My name is Richard. I'm a chiller mechanic. I work for West Tech's chill water specialist in Abilene. Been in the HVAC industry for 18 years. Been with West Tech's for 4 years. Most of it's troubleshooting, logging equipment, mostly chillers. Basically making sure equipment runs right, and when it's not working right, figuring out why it doesn't work right. There's a lot of different aspects of my job as far as movement of fluid, water going through chillers, thermodynamics, moving heat from one place to another basically through refrigerant. There's electrical, lots of electrical stuff, so everything has a formula as far as if you're dealing with electrical, you gotta have, Ohm's law and other stuff like that you have to know. If you're looking for amp draw, if you're looking for resistance, or if you're looking for voltage, basically everything we do involves math at some point. The most common thing I do on a daily basis is logging a chiller, which means I go to the machine and I want to see what it's doing, how it's running, and performing at the time of inspection. So we log it by looking at what the power is doing, as far as how many volts are we sending to the chiller, how many amps is it pulling, how loaded is it, what's the pressure drop across the evaporator, what's the pressure drop across the condenser, and basically you have to figure out, before you do anything, you have to know what the GPM is. So to find out the pressure drop, I've got to know the approach before I can start doing anything. Which basically means I got to find out what the pressure drop across either the chiller or the evaporator is. Basically, the first thing I'm going to have to do is look at my pressure change from the entering water and the leaving water. I look at the design data. If it tells me the design is 14 feet of head, I've got to convert that to delta P by dividing it by 2.31 right off the bat, and that gives me my design delta P. So the first thing I do when I walk up to a chiller is division, and then I've got to find my approach, which is the difference in the leaving water and the saturated evaporator temperature. So I got to subtract is the very next step, and it just gets more and more complex from there, but basically there's not a step that I take with a machine that doesn't involve some sort of math. I'll give you an example of the most recent problem that was pretty tough, and it was a customer asked me to verify the kW of the motor on the chiller, and our chillers don't have kW meters, so there's no way to just say, hey, this is the kW you're putting out. And it's a simple formula to figure out kW. You take the formula is kW equals 1.73 times I times E times the power factor divided by 1,000. The biggest part of that problem is the power factor, because every location has a different power factor. And what made the problem complex is determining what the power factor, and it's a huge math, electrical engineering thing that I'm not really going to get into, but I can tell you that I figured out the power factor was 0.875. Basically, E is energy measured in volts. My voltage was 460 volts. My amp draw was 361 volts. So you multiply the voltage times the amp draw times the power factor divided by 1,000, and I was able to prove this is what your kW is.